What if everything you thought was pure actually wasn't?
Is this water pure? Look closer and question everything.
Before modern chemistry, there were alchemists, and they held an ancient secret.
From Egypt to India to China, distillation's secrets traveled the Silk Road. These rose petals hold something precious. Heat releases their soul.
For centuries, this simple technique created liquid gold from flowers. Today, entire cities depend on this ancient idea. But how does it really work? Desalination plants turn ocean into drinking water. But what's really in that water? 2 glasses of water. One is pure, the other contains secrets. Which is which? For medicines and vaccines, purity isn't just important, it's the difference between life and death. This is simple distillation, beautiful, elegant, and hiding a powerful secret. As water heats, salt crystals release their hold. But where do those ions go? At exactly 100 degrees Celsius, water transforms, but only the pure water escapes. Water molecules escape into vapor. Salt ions? They're left behind, trapped in the liquid. The vapor rises, passes a thermometer, and heads toward the cold zone. But what happens next? Inside the condenser, heat meets cold, vapor surrenders, becoming liquid once more. Drop by drop, pure water collects, the salt, left behind, never to escape. The salt remains behind, crystallized into beautiful but unwanted residue. Pure water achieved. But is it truly pure? Let's test. The meter reveals the shocking truth. Pure? Not quite. Dissolved gases, glass particles, even air itself leaves its mark. But what if we need to separate 2 liquids? Water and ethanol, for example. Now it gets complicated. Enter fractional distillation. Same idea, but with a brilliant twist, the fractionating column.
Thousands of glass beads create countless condensation evaporation cycles. Each step purifies further.
At exactly 78 degrees Celsius, something remarkable happens. Pure ethanol reaches the top. Water, with its higher boiling point, condenses and falls back. Only ethanol continues upward. And there it is, pure ethanol, collected drop by drop, separation achieved. But watch the thermometer. When it rises above 78 degrees Celsius, the ethanol is gone. This isn't a laboratory, it's an oil refinery. And those towers? Giant fractionating columns. Inside, hot crude rises. At different heights, different temperatures yield different products. From a single black liquid, gasoline for cars, kerosene for jets, diesel for trucks, all separated by boiling point. A perfect crystal has perfect order. Add an impurity and the lattice weakens. Melting becomes easier. Pure sulfur melts sharply at 119 degrees Celsius, but add impurities and everything changes. The more impurity, the lower the melting point, the higher the boiling point. A predictable relationship. Pure substance, sharp melt at exact temperature. Impure, lower, slower, messier. The difference is unmistakable. Impurities trap solvent molecules, making escape harder. More heat required, boiling point rises. Paper chromatography offers another window into purity. One spot, pure. Multiple spots, mixture. One spot, pure. Multiple spots, impure. The evidence is right there on the paper. To increase purity, dissolve and recrystallize. Each cycle leaves impurities behind. In pharmaceutical factories, purification isn't one step. It's many, because lives depend on it. Each vial represents countless purification steps, each dose a promise of safety. Every pure substance has unique melting and boiling points, like a fingerprint for chemists. Find the melting point, search the database, and the substance reveals its identity. Even the air around us gets separated. Liquid air distilled into pure oxygen, nitrogen, and noble gases. Nitrogen preserves food, freezes warts, manufactures electronics, all from separated air.
Medical oxygen fills hospital wards, saves premature infants, enables surgery. Pure gas, pure life.
Noble gases helium, neon, argon, each with unique glow, each from the air we breathe.
From sugarcane to car fuel, from corn to cocktails, ethanol distillation powers our world. Pure water for pharmaceuticals, electronics, power plants. Distillation delivers at massive scale. Before any product ships, quality control confirms purity. Science protecting people, every time. Purity confirmed, batch release approved. Simple and fractional distillation, melting and boiling points, chromatography, all tools for purity.
From ancient alchemists to modern labs, the quest for purity drives us forward.
When purity fails, medicines harm, electronics fail, engines die. The stakes couldn't be higher. The World Health Organization sets the standards. Countries enforce them. Patients depend on them. Every food additive, every color, every flavor, tested and certified pure before reaching your plate. Higher purity costs more. Smart science matches purity to need, not Chuecho unattainable perfection. The future brings better membranes, smarter materials, more efficient processes. The quest continues.
Remember, we're separating by boiling point.
Is 85 degrees right for this?
Yes, that's the boiling point for ethanol.
Drops are collecting now.
Good. Note the rate.
Modern distillation embraces sustainability, renewable energy, water recycling, environmental responsibility.
We began with a single drop. Now we understand everything it contains, everything it took to make it pure.
The pursuit of purity never ends, from ancient alchemists to future scientists, including possibly you.